So hopefully you guys did this one. So what's the probability of someone being dead given that they are a smoker? So again, given, right? So first thing we're going to do is find the probability of A and B. So how many people died and also were smokers, which is the same, right? Still 139 over 13.4. So that's going to stay the same. And now what's the probability of A? So the probability of A, in this case, is someone who's a smoker. So how many people were just smokers? So that's the whole thing here. So 582 over 1314, which should give you about 0.443. So now the probability of B given A, right, the answer we were looking for is the division of those two numbers. Or approximately 0.239 as the answer. Okay. And then now, lastly, we go to our final question here, or example here, when it comes to it. Example 8 on the bottom here. So example 8 goes back to our polygon test, a little different type of polygon test in this case. So use drugs, doesn't use drug, positive test, negative test. So A says, if a person is randomly selected, what is the probability the person had a positive test given the person uses drugs? So again, what is our event A and what is our event B in this case? All right, so hopefully you say this is event A, event B, okay? Right, so notice the same template, same format. It's always B, event B, given event A, right, in that template. Okay, going back to our equation, right? So notice we keep going back to this equation, right? So first thing we do, A and B together. So according to our table, how many people got a positive test? So all of these people, and also use drugs. So out of the positive tests, right, all these people, how many just use drugs? 44, right? So 44 out of a total, I did this earlier, 942, I believe, is everybody together when it comes to it. So when we do that, right, divide these two out, you get 0.047 as that answer. And now the next thing is we want to find the probability of A. So A is, again, right, person that uses drugs. So how many people use drugs? So all of these people, right? So 44 plus 6 is 50 out of 942, which is about 0.053. Okay. So therefore, our final answer, right, the probability of B given A is a division of these. So 0.047 divided by 0.053, which is almost 1. It's almost 100%. It's going to be 88 or 0.887, almost 90%. Okay. All right, and the last example for 8 is just the opposite. So I just swapped it on you. So now this is, again, event A, and this is now event B. So the good thing, hopefully you notice, right, it doesn't matter if they swap it, A and B is going to be the same number, right? So probability of A and B is still the same, still 0.047, right? But now the only thing that changes from A and B is, like the part A and part B, is what's defined A, right? So now this time, what's defined to be A is positive test. So how many people got a positive test is now the sum of those. And that's going to be 76 over 942. And that gives you about 0.081-ish. And then our final answer is the division of these two. So 0.047 over 0.081. So about 0.580 is your answer. So again, given is the most difficult, so don't stress too much when it comes to the given probabilities. These are the pretty hardest ones of the probabilities when it comes to it. Okay. All right, so if you flip the page, this page is pretty much a summary of what all the probability is about so far. So what we're going to do is just quickly fill this out. That way you can always go back and give you, a good summary of what we've done so far in this chapter. Okay, so first A is for A. For any event A, the probability is always between what two numbers? Hopefully say 0 and 1, right? Can't stress that enough. If F is a sample space, the probability of S is always just 1, because that's the whole thing. The sum of the probabilities of all disjoint the sample space is equal to 1, and we'll actually get to that far more detail in the later sections as well. Okay. Next one. If A and B are disjoint events, meaning there's no outcomes in common, the probability of A or B is what equation? Hopefully say the additional, right? However, for next one, if A and B are not disjoint, they have one thing in common, then what is the equation going to look like? Probability of A plus the probability of B, and then minus the overlap, right? That's what we did in the last section. Okay. And then for this one, for event A, the probability of not A is just the equation. Again, we'll talk about this far more in the next couple sections going on when it comes to, but for now, I want you guys to just write this down. Okay. And then we're going to skip G. Don't worry about G. And let's go to I real quick. So I says when A and B are independent events, the probability of A and B is equal to what equation? How do we find that? That's what we just did in this section, right? It is the multiplication, right? Ands, because they're independent. However, if they're not independent, therefore our equation is going to look like this, right? It's the conditional part, right? Just like the cards game. So that's essentially is a good summary of what we've done so far when it comes to probability.